Now it is started. Hmm. So we have started doing electric charges and fields. Hmm? Coulomb's law we have studied. Hmm? Coulomb's law is the law to tell what would be the force between 2 point charges. Hmm? And then we have studied what are the relationship, or we can say similarities and differences between gravitational force and electrostatic force. Hmm? Today we are going to study limitations of the Coulomb's law. First thing. Second, we will study the superposition principle. Superposition principle is used to find out the force, electrostatic force due to many charges. Okay. 1 point charge, Coulomb's law tells us about. Okay. 2 point charges, Coulomb's law tells us. If there are many charges, so how to calculate the force on given charge? That is the method given by the superposition principle. Okay. How the medium affects the force? Does the electrostatic force or the Coulomb's force depends on medium also? We will study about that. And then we will study the equilibrium of forces. We will do many questions on it. Practice. Okay. So let us do a quick revision. Properties of charges we studied. Okay. Then we studied Coulomb's law. Okay. So the what is Coulomb's law? Hmm? Coulomb's law states that the force between 2 point charges, there are 2 point charges Q1 and Q2. Okay, Q1, Q2, and the separation between them is R. Okay, then force between them will be equal to K Q1 Q2 upon R square. Okay, here K is a constant that is equal to 1 upon 4 pi epsilon naught. Okay, and this, the value of this constant is 10 raised to the power 10 to the power 9 Newton meter square per Coulomb square. Okay, this epsilon naught is also called permittivity of the free space. What do we call it? Permittivity of free space. This is the permittivity of the free space. Hmm? If I want to write it in terms of vector form, I write force on 1 due to 2 vector will be equal to K Q1 Q2 upon R cube R1 vector minus R2 vector. Okay, and this force is actually directed this way. Hmm? Actually this depends on this, the signs of this also, R1 or R2 also. Okay, then if I want to write F21, then also I can write. Hmm? I can easily write. This is a Coulomb's law. What are the similarities T's between gravitational and electrostatic force? Hmm. First similarity, inverse square law. Both follow inverse square law. Inverse square law. What are the inverse square law? F is directly proportional to 1 upon R square, that is the inverse square law. Okay. Second, both are central forces. Okay. Both are conservative forces. Conservative forces, and both are long range forces. Very good. What is the meaning of central forces? Forces act along the line joining the two charges. That is called central force. Okay. Forces act along the line joining the two charges. That is the central force. And in gravitational, we can say forces act along the line joining the two masses. Conservative force means work done by the force does not depend on the path. It depends on the initial position and final position. Okay. For conservative force, we define potential energy and potential. Okay. Potential energy or potential is only defined for conservative forces. Correct. Then long range forces means they can act up to infinity. Okay. For any distance they can work. Although in very short ranges, these forces become very weak. Very strong. The forces become very strong because their R reduces now. Okay. Now differences. What are the difference? Tell me. First difference: gravitational force can be attractive also. Can be attractive only. Okay. Gravitational force can be attractive only. Okay. Second, hmm? Yes, electrostatic force attractive and repulsive all both, while gravitational force is only attractive. Second difference. Huh? Is we one student. Yes. Gravitational force is not affected by the medium. Okay. Gravitational force is not affected by the medium. Why? The medium. You are going to be confused after some time, because I will write that even the Coulomb force is not affected by the medium, but the Coulomb force between two charges is not affected by the medium. Medium creates a net effect. What it did, we will discuss this. Okay. So limitations of Coulomb's law. Coulomb's law is only valid for point charges. Okay. Coulomb's law is valid for point charges. We can write limitation. Coulomb's law is only valid for point charges. Got it? You have got your PDF material or anything like modules? You have not got? No material yet. They promised me that they will distribute it by 24 hours. Today is the 24, no? Today is the 25. They should have distributed it by now. Okay. Coulomb's law is only valid for point charges. This is the only limitation. Okay. There is no other limitation of this law. Hmm? Now, superposition principle we are going to discuss. Superposition is superposition in all parts of the physics. We have studied superposition of waves also. Okay. Superposition principle in waves. Have you studied? You did not start with the waves chapter? You were not present in the class of the waves chapter? Jubair sir was taking that class, I think. Online, yes. You did not attend that class. Okay. So superposition principle, beta. Very important principle. Superposition principle. Hmm? What is superposition principle? There are two conditions of superposition. First, force between two point charges is unaffected by the presence of any third or any other charge. Okay. Any other charge. Force between two charges is unaffected by presence of any third charge. Between two charges, it will remain the same. That is given by the Coulomb's force. Okay, got this? I'm writing force between two point charges is unaffected by presence of any other charge. Okay, by presence of any other charge, it is unaffected. What does it mean? It means the force between two charges is always given by the Coulomb's law. Okay, let's say these are the two charges, this q1 q2 separated by a distance r, q1 q2, then the force between them will be equal to, force of interaction between them is k q1 q2 upon r square, and k is equal to 1 upon 4 pi epsilon naught. It will always be the same. Second, now if there are many charges present and I want to calculate the force on one charge, then I will individually calculate all the forces and vectorly add them. Forces are the vector. Okay, I will calculate individually all the forces due to all other charges on given charge and then add them vectorly. Okay, I will find out the vector sum of them. Clear? So the net force, net electrostatic or any kind of static force on a given charge is vector sum of forces, individual forces due to all other charges. Are you getting me? Let's say this is a charge q. This is a charge q. Many charges are present around it. q1 charge is present, q2 charge is present, q3 charge is present, q4 charge is present. Many charges are present. Okay, now all of these charges are exerting their forces individually on q. The force due to q1 will be acting along this line. Correct or not? If this is a point, this is acting like this. q2, it will be acting like this only. This only. Correct? Yes or no? Okay, because of q3 it will be acting like this. Oh, it should be a straight line. Like this. Okay, because force acts along the line joining the two charges, and due to 4 it will be acting like this. Like this. Okay, individual forces. Got it or not? Now what will I do? I will name these forces f1, f2, f3, f4. If I want to find out the net force, f net, then what will I do? I will vector sum of them. f1 vector plus f2 vector plus f3 vector dot 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 dot. Got it? So basically we can say that f net on the given charge is actually sum of all the charge forces, okay, starting from 1 to any number of forces n. Got it? You got this or not? We are adding them, vector sum. You know how to do the vector sum? Do you remember that? How to vectorally add the forces? Do you remember that? Hmm? You don't remember? I'm giving a quick revision. How to add two vectors? Vectors are added with the help of parallelogram law of vector addition or triangle law of vector addition. You remember that? Hmm? If these are two vectors, vector A, vector V. So I want to find out the resultant vector of them. Then what will I do? I will draw a parallelogram like this, and this is the resultant of these two vectors. So resultant of this vector R is actually equal to this angle between two vectors is theta. So R will be equal to square root of A square plus B square plus 2AB cos theta. Do you remember this? You have to write down everything, beta. Okay. This is the vector sum. If I want to find out the resultant angle, this angle alpha, then what will I do? I will make a triangle. This is also theta and this is A. So this is A sin theta and this is A cos theta. Okay. So I can say that tan alpha is equal to A sin theta upon B plus A cos theta, beta. B plus A cos theta, tan alpha, this triangle I am taking. Are you getting or not? This is a little mathematics, beta, but we have to do. We don't have any other option. You are noting now? Let me check your notebooks. Noting? Okay. So we can say that alpha is actually tan inverse A sin theta upon B plus A cos theta. Beta, don't try to mug up the formula. Understand from the diagram. Okay. This is known as the vector addition, and we are going to use this in all the questions that we are going to do. We are going to use it. Okay. Note down. First note down this. Very important principle, beta. I have already explained you that in this chapter we have to learn only two principles: conservation of charge and superposition of forces. Only two things we have to learn: conservation of charge and superposition of forces. Everything else is just repetition of these two things. Physics is very simple if we try to understand them from the basics. Noted? Note down? Very good. Note this. Noted? Why this seat is vacant? Why anyone is not sitting on this seat? Does anyone has a reason? Huh? When I was in school, I used to sit on the first bench. Always. I don't know why students try to avoid it. Why do they avoid? Hmm? Do you have any reason? Hmm. Okay. Now we are going to study the effect of the medium. We have discussed in the superposition principle that charge force between two charges is not affected by the medium, but there is a effect on the net force definitely. Okay. So what happens? Let's say there are two charges, Q1 and Q2, and there is a medium surrounding them. Medium. So when medium also has the charges, positive charge, negative charge, so the medium get polarized. Medium get polarized. How does the medium get polarized? let's say there is a force acting between them, and the medium, it is the medium, let's say. Okay, because of the, let's say this is positive charge. If this is positive charge, a negative charge will be developed here. Okay, or we can say that because of this positive charge, you will get that this positive charge is surrounded by the medium molecules like this: negative, positive, negative, positive, negative, positive, and whole of the medium is converted like this only. Are you getting me? So what will happen? The net force will reduce because of the presence of the medium, since the medium itself has polarized and the medium is opposing that force. Okay, is creating the opposite effect. If this force is creating effect on this side, the medium, this is negative, this is positive, so medium is creating effect on this side. This is positive, this is negative. Try to understand from here. This positive charge is creating effect on this side. This is negative, this is positive, so positive charge will be creating effect on this side. So both of the effects are having a reduced effect. They are in opposite directions now. Are you getting me? So the net force will be reduced. The force between two individual charges is not affected, but the net force is affected because of the presence of medium, because medium also has a force. Medium is also creating its own force. Why medium is creating the force? Because the medium is polarized. Okay, so we can say that due to charges, medium get polarized. Medium get polarized. Okay, it creates its own electrostatic effects, which is in opposite direction of force due to given charges. Are you getting the language? Which is in opposite direction of the force due to the given charges. इसका मतलब क्या होगा? Net force F net will be reduced, is reduced. Okay, F net is reduced. Basically F net is F due to charges minus F due to medium. Are you getting me? Is it clear? So F net, the vector sum we will use, F net is actually F minus F medium. Clear? So this F medium is actually written as 1 upon 4 pi epsilon, not epsilon naught, because here the medium is introduced. Naught is for vacuum. Here there is a medium. So force in a medium is given by the net force in a medium. We are saying F net will be 1 upon 4 pi epsilon in a medium. What should I write? Here I write F due to medium. Okay, and I am calling this F net to be Fm. Okay, force in a medium, force in vacuum and force in a medium. So force in a electrostatic force in a medium is equal to 1 upon 4 pi epsilon q1 q2 upon r square. Okay, what was F? This F was 1 upon 4 pi epsilon naught into q1 q2 upon r square. Correct or not? So what is the ratio of F in the medium, F upon F in the medium? What is the ratio? The ratio will be equal to, this is in denominator, na? This is in numerator. Which of the two is bigger? This F or Fm? This F is greater, obviously, because this is the reduced force. This Fm is the reduced force. Are you getting? Not getting? This F is bigger, Fm is smaller. Yes or no? Due to presence of the medium, the force is reduced. Due to the presence of the medium, force is reduced. So which one is bigger? F is bigger. Very good. Now if I take the ratio of them, you will see that this 1 upon 4 pi epsilon naught will go on the upside. Not getting? I am doing here 1 upon 4 pi epsilon naught into q1 q2 upon r square divided by 1 upon 4 pi epsilon into q1 q2 upon r square. What will happen? This will go up on upside. Okay, so you will get, this is cancelled, this is cancelled, this will go on upside. So this will be epsilon upon epsilon naught. Are you getting? So this is epsilon upon epsilon naught, and this is called relative permittivity. Okay, this is permittivity, but relative permittivity, and this is also represented by letter K also. But this K is actually different from this K. That's why instead of using K, we use this ER. Got it? We use this ER so that both of the K can be different. Okay? This is also a constant. This is called relative permittivity. Now one thing is very important, that relative permittivity is greater than 1. Always greater than 1. Isn't it? Because this F is greater than Fm. This epsilon is greater than epsilon naught. Clear? So this relative permittivity is always greater than equal to 1, but it can be equal to 1 when both the mediums are same. So this is always greater than 1. Is it clear? No confusion? This ER for different mediums is given. This ER for water is 81. What does it mean? It means the electrostatic force in the water decreases by 1 by 81. Got it? The electrostatic force in water will be decreased by 1 by 81. Is it clear or not? I will write like this. I am writing. The force in a medium is actually equal to 1 by 4 pi epsilon naught into epsilon r. Are you getting this? Not getting. If I write epsilon is equal to epsilon naught into epsilon r. Correct or not? So this epsilon can be replaced by this epsilon naught into epsilon r. Yes or no? Yes or no? We can replace it by or not? If I write this equation 1, in the equation 1 I can put this epsilon here. Clear? Is it clear or not? Beta, don't talk. What are you discussing? No discussion. So here I can say Fm is equal to 1 upon 4 pi epsilon r into q1 q2 upon r square. Okay. So this Fm is actually equal to this F upon epsilon r. F upon epsilon r, isn't it? This is epsilon r. Clear? So it is, if this is water, if the medium is water, two charges are kept in water, then the force between two charges will be, net force between these two charges will be reduced by 81, 1 by 81. Okay, it will become 1 by 81. Okay, 1/81th part of the original force. That's why the salts, when they are put in water, their bond breaks. Okay, the electrovalent bond between them breaks and they becomes ions. You have studied in the chemistry, na? When the salts are dissolved in water, they converts into ions. Why are they converts into ions? because they are the electrovalent bond, and electrovalent bonds are not nothing but they are bonded by electrostatic force. Okay, so when they are put in water, their force is reduced and it becomes 1 by 81th part of the original force, so they will break. Got it? This is one of the example. Epsilon r for metals is infinite. Okay, epsilon r for metals is infinite. Okay, why we cannot use Coulomb's law for large size bodies? I have discussed that we can use Coulomb's force only for point size bodies. Why can we not use Coulomb's law for large size bodies? The reason is very simple. Let's say this is a body and this is also a body. Both are charged. Let's say both are charged by, both are given some charge, positive charge. Okay, this positive charge will cause a repulsion. This is the center of them. This is center, this is center, and the center between them is actually separated by distance r. Okay, so if the Coulomb's law can be applied on them, it has q charge, and this also has q charge. So if I apply the q1 or q2 can also be different charges are also possible. If I apply the Coulomb's law, the force should be k q1 q2 upon r square. Is it correct or not? No, it is not correct. Why it is not correct? This is wrong. We cannot apply it here. The reason is very simple. Because of this positive charge will be repelled. Okay, so this will not remain uniform distribution. This charge will come this side. Because of the repulsion, this will come on this side. Okay, more charge will be on this side, less charge will be on this side. Are you getting me? Same will happen with this body also. Charge will be repelled, so more charge will be on this side and less on the other side. Okay, so now what is happening? The center of charge has shifted. The center of charge has shifted. The charge is not uniformly distributed, so we cannot assume that it is concentrated at center, because it is not uniformly distributed. It is more on one side, less on other side. So actually the effect, the center of charge has shifted to this point, and here also the center of charge has shifted to this point. So basically the net distance has increased. It has become d, not r. Okay, and here this d is greater than r. If the d is greater than r, then the new force should be, this new force should be less than the earlier force. Okay, so the force new should be less than the force earlier. So we can say for the point charges, the force will reduce if they are both positively charged, or both negatively charged also, then also the force will reduce, because the separation has increased between them. Are you getting me? The center of charges has shifted. Center of charge has shifted. It has, suppose both are charged by opposite charges, then what will happen? Then the charges will be attracted. No, same thing will not happen. No, then the charges will be attracted. They will shift towards this, they will shift closer instead of going farther. Are you getting? Because positive charge will attract the negative charge. If I take the spheres of two different charges, then this will be positive and this will be negative. So now the center of charge has reduced. So now we can say that this was the r, and the new d is actually less than the r. This is r, this is d. D is smaller than the r. If the d is smaller than the r, then we can say net force will increase. Force will increase. Correct or not? Because the distance has reduced, na? If the distance has reduced, then the force will increase. Yes or no? Got it? Is there any confusion in it? No confusion? Oh, very good. Now try to answer this question. Can't say, it is written can't say. Okay, read this question carefully and answer the question. You are not noting down. So we are noting. You have not noted the last slide. Hmm? You have to note it down. How will you revise things otherwise? Huh? You have to note. For the first one, which will remain, which is the correct? C. C is correct or not? Correct? Very good. It will remain same. Why it will remain same, beta? Because the force between the two charges is not affected by any presence of any other superposition principle. The first point of the superposition principle. Okay. Net force on the Q1 will there the third charge is also included in between them, exactly in between them, like this. Increases or decreases. This is Q2, this is Q3, and this is Q1. So increase or decrease? Increase. Okay, because two forces are acting now, F2 and F3. So it will increase, but it will only increase if Q3 is a positive charge or same charge as Q2. Okay, if the charge of Q2 and Q3 is same, then it will increase. If they are opposite, then it will decrease. Okay, it depends on nature, but here we are assuming that they are positively charged only. Okay, now can do this question, just a calculation based question, simple use of formula. Try to solve this question. What is the question saying? You have to note down. You are not noting down questions, you have to note, beta. It is necessary. Note down this question first. Oh ho, it is streaming, not recording. My god. Don't worry, I started recording also. The wrong button was clicked. Don't worry, but it is still can be recorded. Calculate the force between two charges, each of 1 coulomb, separated in air by 1 centimeter. Separated in air by 1 centimeter. We have to just apply the formula F is equal to K Q1 Q2, K Q1 Q2 upon R square. Tell me what is the meaning of this 1? 1 microcoulomb. 1 microcoulomb means 10 to the power, micro is 10 to the power minus 6. Okay, solve it. What is the answer, beta? Huh? 90 coulomb. Force can be in coulomb. Oh Ram. How it can be coulomb, beta? It should be Newton. Now it is correct. Okay. Yes, 90 Newton is the correct answer. 90 Newton is the correct answer. K is 9 into 10 raised to the power 9. Q1, Q2, 1 into 1, 1. And 10 raised to the power minus 12. Okay. Because both are multiplied. And R square, 1 centimeter. 1 centimeter is 10 raised to the power minus 2 meter raised to the power 2. Correct or not? But you have to learn the calculation. I cannot do anything. 9 into 10 raised to the power minus 12 divided by 10 to the power minus 4. Yes, minus 4. So this will be 10 to the power minus 8. Okay. 10 to the power minus 8. From here you can say 10 raised 10 multiplied by 1. So this is 90 Newton. Got it? Okay. This question, it's an interesting one. Okay. What is happening in this question? First read this question, then I will explain. Okay. There are actually two bodies, three bodies. There are three identical spheres. Identical spheres, beta. Okay? Identical means they are made of the same material, same metal, and they have the same radius, diameter, same density, everything. Okay? Identical means this. So first, what are they doing? They are, A and B have some charge, same charge, obviously they have the same charge, and they are separated by distance r, and there is a force acting between them, F. Okay? We are assuming that they have the charge q. So the force will be k q square upon r square. Correct? Very good. Now they are doing A and B, A and C are touched. C has zero charge. What is happening? A and B are touched or what? First they are touching A to C. A to C. Okay? When A to C is touched, what will happen? The charge on A and charge on Q will be equally distributed. What is the charge on A? Q. What is the charge on C? 0. After touching, both of the charge will become Q by 2, Q by 2. Correct? Very good. Now they are touching C to B. What is the charge on B? Q. What is the charge on C now? Q by 2. After adding, both the charges will become 3Q by 2. 3Q by 2, na? 1.5Q. 1.5Q. Half of this will be 3Q by 2. 3Q by 4, sorry. 3Q by 4. Correct? 3Q by 2 divided by 2 is 3Q by 4. So now the charge on C is 3Q by 4. And the charge on A is Q by 2. And you can calculate the force. Now you can compare it with the original force F. Are you getting? Are you getting the process? Not getting? Okay, let me help you. The A and B. A has the charge Q. B also has the charge Q. A has the charge Q. B also has the charge Q. Okay? The force between them is KQ square by R square. Separation between them is R. Okay? Now, this A, which has the charge Q, is connected with C, which has charge 0. Okay? It is connected like this. It is connected. As soon as it is connected, the charge is redistributed. When the charge is redistributed, the A has charge Q by 2 and the C has charge Q by 2. Correct? Now again, this Q is touched with B. Okay? I think it is touched with B only. Yes. So this C and this B has the charge Q, C has the charge Q by 2, and they are connected like this. Okay? As soon as they are connected, the net charge will be 3Q by 2. Divided by 2 is 3Q by 4. So now the new charge on both the bodies will be 3Q by 4. So I can say the charge on C will be 3Q by 4 and charge on B will also be 3Q by 4. Now they are asking force between, now the force between A and B. No, A and B, not A and B. It should be C is taken away. Now the force between A and C they should ask. A and C. Okay? A and C they should ask. Or A and B also. That is also correct. We can ask between A and B also, because B also has the 3Q by 4. C also has the same force. Correct? So if I find out the force between A and C, what will get? We will get that A has the charge Q. Q only, not Q by 2. Sorry, Q by 2. It has Q by 2. Okay. And B has the charge 3Q by 4. So net force will be F dash will be K into Q by 2 multiply by 3Q by 4 divided by R square only. Correct? So this is actually 3Q by 8. 3 by 8 KQ by R square. And this KQ by R square is nothing but F. Correct? So we can say that F dash is equal to 3 by 8 F. Okay? Got it? It's a good question. Such kind of questions are asked in your examination. You got the question or not? Note down. Note down the question. I think this font should be small. Hmm? This is much bigger font. Yes. It should be. I use 30 font size 30. It should be, I think, 28 or 27. Hmm? Then it will be good. Okay. It's too big font size. This class is small, not very big class. Note it down. Note it fast, beta. Don't take too much time. What are you eating? You should not go out. Hmm? Immediately. Who are eating chewing-gums, beta? Anyone else? Don't eat anything during the class. Okay? It is already written in the first home page of the screen. Hmm? Don't eat anything on the class. It is basic manners. We should not do things like this. Okay. Try to do this question. It's a very simple question. It's a very simple question. Okay. It is saying that there are two bodies which have the same charge. Okay, same charge. Exactly the same nature also. Okay. One charge is reduced by 20% and this charge transfers to the other body. Okay. 20% of one charge on one body is transferred to the charge on the other body. Am I telling the correct question? Yes, sequence is correct. Okay. So some of the charge from the one body is transferred to the other body. 20% is transferred. Okay. Let's say initially it has 1 coulomb charge. So 0.2 coulomb is transferred. Correct? 20% means 0.2 coulomb. So now what is the charge on A initial body? It is 0.8. What is the charge on other body? 1.2 beta. 1.2. Correct? So first find out the initial force, that is F. F is equal to K Q square upon R square. Correct? What is the F dash? F dash will be K 0.8 Q multiplied by 1.2 Q divided by R square. Are you getting it or not? Because the values of charges have changed. What is the net force? 0.8 multiplied by 1.2 into F. Correct or not? Do this. I will check in your notebook. Beta, do yourself. Don't talk. What your name? Your. Yes. Krishna. Tushar. Okay. Tushar. We have to solve at least 100 questions per day. Then we will score 650 marks. If we want to score 650, then we should solve at least 100 questions per day. Yes, that is the condition. In each subject, you have to do 100 questions for scoring 650. You can, because we know that some of the days we will not be solving the questions. So average will be about 80 questions per subject. So 80 questions per subject per day is needed, beta. We cannot do less than that. Hmm? Okay. Should I solve it? So the F initial force will be K Q square upon R square. F dash will be equal to K 0.8 Q multiplied by 1.2 Q divided by R square. Yes or no, beta? Yes or no? Okay. So this F dash will be equal to K 1.2 multiplied by 0.8 is 1.2 multiplied by 12 8 times 120. 12 8 times is 9.6. Huh? 9.6. Okay. 0.96. Very good. I'm very bad at calculations. So you have to help me always. I will avoid doing the calculations. I will ask you to do the calculations. So this is 0.96 times of the initial F. Now you are checking that force has reduced because of the transfer of the charge. Force is maximum when both the bodies have the same charge. Force is maximum when the both bodies have the same charge. Okay. If they have an unequal charge, then the force will be reduced. Got it? If they have unequal charges, then force will be reduced. If they have the same charge, then the force will be maximum. Force will be maximum when both the bodies have the same charge. Got it? Now, exactly the similar question, just a little difference. Just a little difference. Here, the bodies don't have same charge. Bodies have opposite charges but same magnitude. Opposite charges but same magnitude. Okay? So, can you solve this? Try this. I'm giving this question in homework. Note down and I will check next day. Note down this question. Note down this question. Fast. Noted? Noted fast. Done? Very good. This question. This point is good. I think this point is good, na? Hmm. Hmm. Specific charge means Q upon M, beta. Charge per unit mass. What is the question saying? Who will tell me? Who is going to explain the question to me? Who will explain the question to me? What is the question asking? Hmm? Yes? Does anyone want to tell me? There are two charged bodies. All charged bodies have masses also. Okay? So there are two forces acting. One is the electrostatic force and other is the gravitational force. Okay? Since the charge is same, therefore the electrostatic force should be repulsive force and gravitational force is always attractive force. But the bodies are in equilibrium. What does it mean? It means the gravitational force and electrostatic force are equal. They want to find out the Q upon M. Can we calculate? We have to just write that gravitational force is F G, let's say, and electrostatic force is F E. Gravitational force is G M1 M2, or since the bodies have the same mass, na, equal charges and same mass, so M square basically divided by R square is equal to K Q square upon R square. R square cancels R square. We want to find out Q upon M. So Q upon M whole square is equal to Q upon M whole square is G upon K. So here Q upon M will be equal to square root of G upon K. Do you know the value of G? The capital G? 6.67 into 10 raised to the power minus 11. Do you remember this? Am I right? Capital G, universal constant G. Correct. It is 67 or 66? 67, na? Yes, correct. And K is 9 into 10 raised to the power 9. Okay. I am not writing units. Because I already know the units. The final unit will be charge per coulomb of this ratio, the charge per kg or coulomb per kg. So from here you can calculate and this will come some value. It is your homework. Find out this value in homework. I will not do calculations for you. Is this your book? This is my book. I will use it. It's a good book. It has summaries of all the chapters, well concised. Okay. Done? Done or not? I will check the homework, beta. I am very sincere about it. I will ensure that you score more than 500. After that, it is your hard work. Okay. I will ensure that you score more than 500. After that, it is your hard work. I have given you mantra. What is the mantra? You have to solve at least 80 questions per subject per day. If you solve that much questions, you will definitely score 650. This one question. Note down this question. This is also in homework. This is very simple question, beta. This is saying maximum force. Maximum force is only when charge is equal. Charge is equal means 12 coulomb is divided into two charges, 6 coulomb and 6 coulomb. Okay? Correct or not? 12 coulomb charge can be distributed in any part. 1, 12, 3, 4, 10, 11, 11, 1. You can divide any. Okay? But the force will be maximum when both charges are equal. So then you have to find out the maximum force also. Note it fast. Noted, beta? We are running behind the plants syllabus. Okay? Because there were not two classes in this week. There's one question. You did not note down? Note it fast. Noted? What your name? Javed. I know two names today. One is Javed, one is Tushar. Okay. Am I not pronouncing it correctly? It's good, na? Okay. Even if I'm pronouncing it wrongly, it doesn't matter. He's Tushar for me. Hmm? Krishna. Krishna. Anyone has the name Krishna here? Who is the Krishna? No, he is not Krishna, na? He is Tushar, na? He, both. He also has the name Krishna. Do you have Krishna name also? Okay, don't worry. Okay. It doesn't matter, beta. Noted? Okay. Names are just names. Why are we worried about the names? Note down this one also. A particle of mass m carrying charge q1 is revolving. This is a good question. Okay. How this question can be? No, it cannot be done in homework. You cannot solve this question in homework, beta. Is it a good circle? Very good. Although tools are given, still I try to draw it. Okay. There is a charge minus q2 here. Okay. And this q1, that is positive charge, is revolving around. This q particle carrying plus q1 charge is revolving around a fixed charge q2. Okay. This is minus q2 and this is q1. Q1. This q1 is revolving around it, beta. If it is revolving around it, it means which force is providing the centripetal force, beta? For any kind of revolution in circular path, circular motion is only possible when there is a centripetal force. So who is providing this centripetal force, beta? Electrostatic force is providing the centripetal force. Correct? Which force is providing the centripetal force? Electrostatic force. So what is the electrostatic force here? Electrostatic force is F is equal to K Q1 Q2. Why this negative sign? It means attractive force. Attractive. Okay? Upon what is the radius? R. So R square. Got it? Now centripetal force, we know that centripetal force is equal to m omega square R. Do you remember this? You don't remember? I know it. You don't remember. Centripetal force is m omega square R or m v square upon R. It is the same thing. What is omega, beta, here? Omega is angular velocity. Omega is angular velocity. Angular velocity. Okay. Angular velocity. That is omega. Okay. Both are equal. It means k q1 q2 is equal to m omega square R. But from here you can calculate omega. Can you calculate omega or not? Yes or no? You can calculate omega. If you can calculate omega, do you know what is the relationship between time period and omega? The question is asking speed, time period or revolution and speed also. Speed means v. V is actually nothing but omega is equal to v upon r. Yes or no? Yes or no? Okay. So from here you can easily calculate v is equal to r omega. Correct? Time period t is equal to 2 pi upon omega. Yes or no? Okay. What is the value of k here, beta? K is equal to 1 upon 4 pi epsilon naught. Don't put the value 9 into 10 to the power 9. Okay. Put this value because pi will cancel the pi for time period. Okay. For speed, you should put this 9 into 10 raised to the power 9 value. Got it? You will get the answer. Yes or no? You will get the answer. Note it down. In homework complete, I need this. Although I have solved this question completely, you have to just do the calculations. I am not going to do the calculations. You have to do the calculations. Don't sit like this. You should sit here. Otherwise, sit here. That is a better place. Okay? What your name? Zaved. Okay. Noted? Noted fast, beta. Note it fast. Next. Find net force on B. This is B. Okay? This is charge Q. This is charge Q. This is also charge Q. Find net force on B. Note down this question. This is also homework. Very simple question, beta. Very, very simple question. How to calculate it? This will exert a force like this. This will exert a force like this. Angle between those forces is 90 degree. Apply the Coulomb's law. You will get the final answer. Yes or no? Okay, very good. Do it. In homework. In homework, do this. Noted? Next question. Beta, same type of question, only angle is changed. Noted also. This force, okay? Correct? The angle between two forces is 60 degree only. Okay? Find out. Note it down. This is also homework. This is also homework. Note it down. I will check the homework, beta. And I will decide some punishment also for those who do not do the homework. Noted? Noted. Very good. You did not note that. Okay. Noted. Noted. Noted? Done? Very good. This one question I have not given the diagrams here. Diagram is this triangle. Okay. This has Q, Q, Q. This is A, B, C. This is equilateral triangle, beta. Side, oh, what happened? A, A, A. Side is equal, beta. Equilateral triangle. Find the force on at B. This is question number A. Side A, 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 B, C. This is Q. This is also Q, but this is minus Q. Okay, not exactly Q. This is the question number B. Third question is when this is minus Q, this is plus Q, this is minus Q, this is A, B, C, and this is A, equilateral triangle, question number C. All in the homework. Superposition principle, beta. Vector sum of the two forces. This is a question of vector, not of the force. Okay? Noted? Note it down. Fast. To the time. We have the time. We have the time. I will give a lot of homework. How to do this question? Let me explain you. Okay? This force will be like this. This force will be like this. And you know this is 60 degree. So the resultant will be on this direction. Upward. Correct? Both these forces are equal, F and F. So you can easily calculate the angle between them is 60 degree only. We have done this question, beta. We have already done the earlier question. The question just before it. Is it the same question or not? Okay. in this question, this force will be attractive force this direction, this force will be attractive this direction, exactly the same question just like the previous one. In this question, this is minus q, so this force will be this direction, and this is q, this force is this direction. So this is 60 degree, it means this is 120 degree. Just angle is changed, beta. Resultant will be this. Yes or no? I have solved these questions now. Net force on q placed at the center of the point P as shown. Okay. Hmm. Q, 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 and this is the center of the triangle. Okay. This is equilateral triangle. Side A, side A. This is the center P. Okay. The charge Q is placed here. So what is the net force on this charge? Okay. Then is Q, 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 Q. Each side is A, A, A. This is a center P, charge here. You can easily tell that it is 0. Why? Both forces will be balanced. All forces will be balanced. Forces are equal in all directions and they will be balanced. Okay. But you will do this in homework. Changing a little question. Okay. This is minus q. This is plus q. This is plus q. Okay. And this is the center P. Exactly the center. This same center. And this is q. Okay. Here the same square q, q, minus q, and the center, this is the center P, and this is the center P, and it has charge q. Solve this one also. Okay. One more question I can give you. Q minus q plus q minus q. Okay, this is plus q. Okay, and this center P, the charge is q. Okay, you can do all of these questions. Try them in homework. Yeah, sufficient now? Okay. Yes, time is already, I think, over. Note down. Noted. Uh, okay, time is also over. I will check the homework, beta. I'm saying it again and again. Lecture number 3. Is this the lecture number 3 now? Okay. Saved in which document? I don't remember. I think it is saved wrong at the wrong place. I have to save it. Export document PDF. It should be saved in documents only. Uh, Documents. Save. See you in the next class.
Tushar, what are galvanic cells? Stand up. Ma'am, voice is not coming. Hello, hello. It's coming, it's coming. It's coming. Bolo. Okay. And what is electrode potential? Hmm. Solution and Rohit. Electrode potential. Hmm. Sit. Difference between cell potential and EMF. Sit, Tushar. Beto. Hmm. You were there yesterday. Then I told all of you to revise and come. Rohit number 2 is not there today. Where is Rohit? 2 Rohits were there, no? Absent. Hmm. बोलो. ये तुम लोग ऐसे करके क्यों आंसर देते हो? हाँ, ऐसे खड़े रहते हैं. स्टूडेंट्स आर सपोज टू स्टैंड लाइक दिस. तुम लोग कॉलेज में जाओगे ना, पिट जाओगे. बोलो. Which definition? Cell potential or formula to calculate EMF. Sit. You रामचरण ना. हाँ. हम्म. क्या? बोलो. नोटबुक बंद, नोटबुक बंद. तुम्हारी भी बंद. LNG बंद. हाँ, EMF का फॉर्मूला. कैल्विन. नो नो क्या होता है यार? मैं भी बोलूंगी, कुछ पूछोगे तो नो. फिर जावेद. EMF हाउ टू कैलकुलेट. हाँ. भानु. यू टोल्ड ना. यू टोल्ड. यू टोल्ड. हम्म. सिट. तुम लोग का क्या करना है? बोलो. डंडा वंडा मारना है? क्या करना है? I told na revise to come. While going also I told. And Monday you are having test. Hmm? Pura chapter. And solutions is also coming. Colligative properties. I don't know. Online classes were there, you guys didn't attend. Your fault. That's not any faculty's fault. Then it's your mistake you didn't attend. And still you are sitting with that attitude कि क्या करना है यार, वो तो था ही नहीं. It's very bad. It's very bad. मतलब तुम लोग या तो टाइम पास करने के लिए यहाँ पे बैठे हो या पढ़ना ही नहीं चाहते हो, है ना? दिस इज द थिंग आई एम फीलिंग. किसी का भी एटीट्यूड ये नहीं दिख रहा है कि हाँ मुझे पढ़ाई करनी है. दैट्स व्हाई यू आर स्टेइंग इन हॉस्टल. कल की पढ़ाई हुई चीज आज नहीं आ रही है. Simple formula I'm asking. Yesterday what we did only basics. Even numericals also we didn't do, right? No numericals yesterday. Then बैठो. Reaction question we did yesterday, है ना? How to write reaction question Q बताया था ना कल. Did we do this question yesterday? दोनों? Both we did ना? First one we did. Second one, then do now. Second question, anode cathode reactions you tell. Hmm. Which is the anode part? SN. Reactions, are you able to write? Reactions? जिनका आज फर्स्ट डे है, listen carefully, I'm explaining again, okay? On the left hand side we write anode, on the right hand side we write cathode. So if you see anode में your tin SN is converting to what? SN 4 plus. How many electrons it will lose? 4 electrons. On the cathode side you have Cl2. So Cl2 is converting to how many electrons it will give? It will gain. Huh? You will balance chlorine atoms as well. Okay? So 2. Now next thing I told you yesterday, whenever you are adding two reactions, your number of electrons should be same. Now what to do? Hmm? Here in one equation you have 4, here you have 2. Then what will you do to balance electrons? You will multiply this equation by 2. Your net cell reaction will be net cell reaction Sn plus Q value you write. हो गया? क्यों? क्या लिखना है? कॉन्सेंट्रेशन ऑफ इनटू अपॉन Cl2 गैस होगा तो प्रेशर ऑफ गैस पावर 2. ठीक है? रिटर्न. चलो, नेक्स्ट इज चेंज इन गिब्स एनर्जी एंड ईएमएफ ऑफ द सेल. क्या हुआ तुषार, इतना क्यों बात कर रहे हो? सिट एट द बैक, सिट एट द बैक. व्हाट इज गिब्स एनर्जी? गिब्स एनर्जी नाम सुना है ना? हाँ, किस लेटर से रिप्रेजेंट करते हैं? जी, कैपिटल जी. ठीक है, क्या होता है? क्या कर रहे हो? हाँ, जरूरत नहीं है, अंदर डाल दो. Gibbs energy, that is your delta G. It is basically useful work done by the cell. See, last year thermodynamics में you studied about PV work done, है ना, pressure volume. But यहाँ पे तो हम cell के बारे में पढ़ रहे हैं, so it will be non PV work. So that would be electrical work done, whose value will be minus of charge into potential difference. ठीक है, नोट करो पहले इतना. Done? Done? Yes or no? ठीक है. Okay. Now listen here, stop writing. Everyone listen here. Suppose we are transferring electrons from anode to cathode. You are transferring n mole of electrons. ठीक है? Tell me what is the charge of one electron? Charge of one electron. 1.6 into minus 19 coulombs. That is charge of one electron. What will be the charge of 1 mole electron? Huh? 1 mole means how many electrons will come? Yes. So this value into Avogadro's number, that is 6.022 into 10 to the power 23. So this value comes as 96500 coulombs, which we call as 1 Faraday. यहाँ तक कोई डाउट है? हाँ? Anyone having any doubt? Okay. Now, can I write charge transferred by n mole electrons as NF? लिख सकते हैं? So work done by the cell in transferring n mole electrons from anode to cathode will be equal to how much? What we were writing, electrical work done as Q into V. So here Q is what? NF. V means E cell. So here value comes as delta G is equals to minus NF E cell. If we take at standard conditions, so delta G naught should be equal to minus NF E naught cell. क्लियर है यहाँ तक? पक्का? Any doubt? Anyone? What are the standard conditions? जोर से बोलो यार. Standard conditions means what are the temperature and pressures? 298 Kelvin and 1 bar pressure. ठीक है, लिखो. Done? Yes or no? Done? किसका बचा है? Write fast. Done, everyone? Next is condition for spontaneity. Stop talking. जिसको बात करना है प्लीज बाहर चले जाओ. For a cell reaction to be spontaneous, your delta G value should be what? Positive or negative? बोलो. Delta G should be very good. Negative. If delta G is negative, E cell should be positive. If delta G is 0, E cell will be 0, means reaction is at 0, equilibrium. If delta G is positive, E cell will be negative. Reaction will be non-spontaneous. Done? Done? Chalo. Next is Nernst equation. This also you understand first. यहाँ पे देखो सब. Delta G, one formula is there again from the last year. Delta G is delta G naught plus RT ln Q. Okay. What is the formula of delta G? Just now we derived that one. Delta G is minus NF E cell. Delta G naught will be E naught cell plus RT ln Q. Now if I divide full equation by minus NF, ठीक है, माइनस एन एफ से पूरा इक्वेशन डिवाइड कर दिया, व्हाट विल आई गेट? ई सेल माइनस नहीं आएगा ना, माइनस एन एफ से वी आर डिवाइडिंग. ई सेल विल बी ई नॉट सेल minus RT by NF ln Q. In chemistry we use log base 10 and ln जो होता है that is log base E. ठीक है, we use this वाला log. Now to convert it we have E cell as E naught cell minus 2.303 RT upon NF log Q. Q you know how to write? Reaction question. Now if I put all the values here and measure at 298 Kelvin temperature, ठीक है, putting R value as 8.314, T 298 हो गया, F is constant. So reduced formula I get as 0.0591 upon N log Q. This is your Nernst equation. Note it. Done? Done? Using Nernst equation for half cell. Okay. Suppose we have oxidation half means M solid is converting to Mn plus. ठीक है. Reduction half में what reaction will take place? Reverse. Mn plus will gain electrons and will form M solid. Now how to write Nernst equation for these reactions? Can you try? You have to write E cell. Acha, one more thing. When you are calculating E cell, how E naught cell you will calculate here? E naught cell कहाँ से आएगा? Hmm. E naught cell, how will you calculate? Hmm. This E naught cell will be your E naught cathode minus E naught anode. ठीक है? ठीक है. Just try how will you write the Nernst equation for these two reactions. हो गया? What will be the value of Q? What will be the value of Q? Product upon reactant. So product is Mn plus concentration of Mn plus reactant में we have solid, so we won't include it. ठीक है? And since this is the oxidation half, instead of writing E naught cell, you can write E oxidation potential as well. ठीक है? यहाँ पे बोलो this part reduction में क्या होगा now? Same 1 by Mn plus. Done? चलो next is Nernst equation for hydrogen electrode मतलब SHE. Tell me the reaction for anode. If SHE acts as anode, what reaction will happen? H2 gives rise to, okay. If I write Nernst equation for this, it will be E cell is equals to E naught cell, means I can write E naught of H2 to H plus minus, ruko, wait, stop writing, listen first. Minus upon 2 log of H plus power 2 upon pressure of H2. गैस है तो प्रेशर होगा. ठीक है? What is the value of E naught for hydrogen electrode? 0. ठीक है? E naught will be 0. If we take pressure of hydrogen as 1, your E cell value will be 0 minus 0.0591 upon 2 log of only H plus का square upon 1. I took pressure as 1, this value as 1. Correct है expression? Do you know the log property? Log A to the power B is B log A. पता है ये? नहीं पता है तो पता करो. ठीक है? We can apply this property here. Log A to the power B क्या आएगा यहाँ पे? What will come? 2 into log of H plus ion concentration. Can I cancel this 2 and 2? Multiplication में cancel हो जाएगा. E cell is equals to 1 second 0.0591. I am writing it as negative log of H plus ion. ये क्या होता है? Negative log of H plus ion is pH. तो हमारे पास फॉर्मूला आ गया E cell is equals to 0.0591 into pH. But this formula directly you can use only when pressure is given 1. ठीक है? If pressure value is anything else apart from 1, then you have to take whole equation. Okay? कोई डाउट है यहाँ पे किसी स्टेप में? Anyone having any doubt? क्लियर है? ओके, नोट करो. written, written. हो गया? If it is acting as cathode, reaction क्या होगा? 2H plus will give H2. E cell will be E naught of H plus 2 H2 minus log of pressure of H2. Again, if we take pressure as 1, then क्या आएगा? Log of 1 by H plus का square minus 0.0591 upon 2. Can I write this part as H plus to the power minus 2? लिख सकते हैं? E cell is equals to 0 minus 0.0591 by 2. पावर सामने. Can I write this as 2 बाहर लिख रही हूं मैं, माइनस ऑफ लॉग एच प्लस. हाँ, अगेन माइनस ऑफ लॉग एच प्लस इज पी एच. तो हमारे पास और ये 2 कैंसिल, तो आ गया माइनस 0.0591 इंटू पी एच. ठीक है, क्या डिफरेंस आया एनोड वाले फॉर्मूले में और कैथोड में? साइन. ठीक है, रिटन ऑल ऑफ यू, रिटन. क्वेश्चन, जल्दी से पहले क्वेश्चन नोट करो क्विकली. क्वेश्चन रिटन. फर्स्ट ऑफ ऑल व्हाट यू विल डू, सेल दिया है, रिप्रेजेंटेशन दिया है, इलेक्ट्रोड पोटेंशियल्स आर गिवन. फर्स्ट थिंग व्हाट यू विल डू इज, हाँ हाँ यस, राइट द नेट सेल रिएक्शन. Which part is anode? Which part is anode? Left side, SN wala part. Right reactions. For writing Q part, you should know the net cell reaction. Means products and reactants you should know. Net cell reaction. Done? How many of you are able to do net cell reaction? How many? Raise your hand. Confidently. It will be right. Only two. Manu? हाँ या ना? Yes or no? I can't hear you. और जोर से. No मैम ना? Yes. इनायत? No. रामचरण? क्या कर रहा है भाई? हाँ? हेलेन? कैल्विन? हम्म? तुम लोग क्या किए कल घर जाके? हाँ, हॉस्टल जाके क्या किए? टाइम पास? दिस इज योर नेट सेल रिएक्शन. ठीक है, यू हैव टू फाइंड व्हाट ईएमएफ ऑफ द सेल. Nernst equation you will apply. What is the value of E naught cell? E cell तो निकालना है. ठीक है, EMF you have to calculate. So E cell you will find. What about E naught cell? इसकी वैल्यू E naught cathode minus E naught anode. कितना आ रहा है निकालो. What is E naught cathode? E naught cathode is 0.13 minus कितना आएगा 001. दिस इज योर E naught cell. ठीक है, क्यू में क्या लिखेंगे? क्यू पार्ट concentration of SN2 plus by concentration of Pb2 plus. ये तो सारे सॉलिड्स में होंगे. E naught cell you have, this value you have. SN2 plus का concentration is 1 molar and Pb2 plus का कितना दिया है? 0.001. Can I write it as 10 to the power minus 3? निकालो, solve करो. Put the values, find answer. हाँ, कैलकुलेटर, नीट में कैलकुलेटर मिलेगा तो कर लो. यूज कैलकुलेटर्स इफ यू विल गेट इट इन नीट. आई डोंट हैव एनी इशू. एटलीस्ट करेक्ट आंसर तो निकालोगे. सो जा बेटा, सो जा. गुड नाइट. फॉर नाउ यू टेक दिस एज 0.06. ठीक है, हो गया इजी. कितना आएगा? 0.03. ठीक है. लॉग ऑफ ये हो गया 1 अपॉन 10 to the power minus 3. इफ यू टेक दिस अप इट विल बी 10 to the power 3. 3 log 10, 0.01 माइनस 0.03 और ये वैल्यू हो गई 3 log 10. ठीक है, log 10 इज 1. तो 0.01 माइनस 0.03 इंटू 3. इतना कैलकुलेट हाथ से नहीं कर सकते? नहीं कर सकते? 3 3 जा, मैं पूछ रही हूँ। चलो इतना तो पता है। कितना आ रहा है ई सेल? माइनस 0.08 वोल्ट्स। दिस इज योर ई सेल। ठीक है। एनीवन हैविंग एनी डाउट, एनी स्टेप? पूछो, तुम लोग बना नहीं रहे हो। आई एम सीइंग यू आर नॉट एबल टू डू। यू आर हैविंग डाउट बट स्टिल यू आर नॉट आस्किंग। अब मुझे सपना थोड़ी आएगा किसी को कौन से स्टेप में डाउट है। अगेन एंड अगेन आई एम आस्किंग कि पूछो, डाउट है तो। हाँ, नो, यू हैव टू कैलकुलेट ई नॉट सेल वैल्यूज। दे विल प्रोवाइड यू इलेक्ट्रोड पोटेंशियल, दिस वैल्यू विल बी गिवन इन द क्वेश्चन। माइनस करके बस तो निकालना है। ओके, फर्स्ट पार्ट ऑफ क्वेश्चन इज डन। लिसन, spontaneity, reaction will be spontaneous or not? E cell नेगेटिव है, मतलब रिएक्शन इज नॉन स्पॉन्टेनियस। नेक्स्ट, सेम काइंड ऑफ क्वेश्चन। अब ये बनना चाहिए। यस। एटलीस्ट रिएक्शंस जल्दी से लिखो क्वेश्चन लिख के। नेट सेल रिएक्शन यू शुड राइट। सेल रिएक्शन, एनोड, एनोड रिएक्शन। बोलो। H2 converting to H plus. It will give 2 electrons. Cathode, what is there in cathode? Fe3 plus converting to how many electrons it will give? 1. Can I add the two reactions? Can I add the two reactions? Huh? Number of electrons are same. What you have to do? Multiply this by 2. Now can I add? Net cell reaction bolo. H2 plus 2 Fe3 plus gives 2H plus. ओके, इसके बाद मुझे ई नॉट सेल की वैल्यू बताना. ठीक है, E naught cathode minus E naught anode. Anode is your hydrogen, so it will be 0. Okay? So it will be just minus 0.17 volt. आगे solve करो. Put values in Nernst equation. Q, Q, Q. Minus 0.17 minus 0.0591 upon 2 log of H plus square into Fe2 plus का square upon pressure of H2 into Fe3 plus का square. ठीक है, वैल्यूज बोलते जाओ. H प्लस कितना दिया है? इधर देखो, कैलकुलेशन में प्रॉब्लम हो रही है तो सी हियर. H plus concentration is this. Can I write 10 to the power minus 3? हाँ, ध्यान दो इधर. 10 to the power minus 3 का स्क्वायर है. It will be 10 to the power minus 6. Fe2 plus is 0.01. That is 10 to the power minus 2. उसका स्क्वायर 10 to the power कितना हो जाएगा? 4 अपॉन प्रेशर ऑफ H2 0.1 है, मतलब 10 to the power minus 1. Fe3 plus स्क्वायर है 10 to the power minus 2. सॉल्व हो जाएगा 4. अब देखो यहाँ पे द न्यूमरेटर इट विल बी 10 to the power -10, डिनोमिनेटर में 10 to the power -3, दिस विल गो अप, क्या आएगा लॉग के साथ 10 to the power -7, सॉल्व हो जाएगा, -0.17 माइनस ले लो भाई 0.06 ले लो बाई 2, अगेन दिस -7 विल कम हियर, वो माइनस और ये माइनस, प्लस 7 log 10 इज 1, जल्दी से कैलकुलेट करो, आंसर इज यू विल टेल। नेक्स्ट क्लास से मैं इतना सब कैलकुलेशन करके नहीं दूंगी, है ना। जीरो जीरो फोर प्लस और माइनस, प्लस 0.04, ठीक है, चलो थैंक यू।